Let's look now at how to create attributes which have more than one component, such as vectors or colors. We can lay down an attribute create as before, and let's rename our attribute. And there are two ways to create multi-component attributes, one of which is to keep the type as a float and increase the size. So for example, that would create a 3-component float attribute. Or we can choose the vector attribute, which automatically has 3 components. Let's start by looking at the float. And I'm going to give it values 1, 0, 1. And if we have a look at a details view, we can see that indeed we've got a 3-valued attribute, a 3-component attribute. And I can check that's working by laying down a point sop and using it to add color to our points. And in the add color parameters here, we've got 3 variables. And we want to draw on the values here of myvar. For a single component attribute, we just use $myvar. But because we've got 3 components here, Houdini has created, in fact, 3 variables, and they're $myvar1, $myvar2, and $myvar3. And we should see that we now have some color attributes, and we do, which have the values drawn from myvar, and we can see that our object should now be colored. There's a fault on the display here. That should in fact be a light purple color. You can see a bit of it there. So that's how to use a 3-component attribute which is made up of the float type. Let's now add an attribute which is a vector. So this time I'm going to call it myVec, and I'm going to give it the value of 1, 1, and 1. I'm going to bring up the display options for the 3D view, and in fact I've already created a custom option here for displaying myVec, so I can enable that, and we should see our vectors, and they all point in the same direction, which is 1, 1, and 1. The distinction between a 3-value float and a vector is to do with what happens when you transform the object which the attributes are attached to. In this case, if I go up to the scene level and rotate my object, so let's rotate it like so, and I'm rotating it until those vectors are more or less pointing straight upwards. So in other words, in a world coordinate system they would have a y value of 1 and an x and z value of 0. But if we go back inside, we can see that that transformation hasn't affected the values of myVec. Those are still 1, 1, and 1. However, Houdini knows that this is a vector attribute and needs to take account of the transforms. So if you were to use this attribute in shading, what you would get is not the value 1, 1, 1, but a value that's been transformed using the transforms that apply to the object. In fact, it will have been transformed into the camera coordinate system as well, which is the coordinate system which is used by Mantra for rendering. We can see this at work using an object merge. So I'm going to lay down a geometry node, dive inside, and bring in an object merge. And we'll set it to import our sphere. And we can see at the moment those values of myVec are the same. And that's because by default there's no transformation happening. If I transform, however, the sphere into the coordinate space of this object, and remember this object has no transforms applied to it, the effect of that is to apply the transforms here to that attribute, so that when it's brought in here we can see that we no longer have 1, 1, 1, we have some values which are much larger in the y direction. In other words, some values where the vector is pointing almost straight up. So that's the important difference between a vector attribute and a three-component float attribute. The vector attribute will be transformed into the relevant coordinate system. Let's look now at how we change the type of our attributes. So I'm going to lay down an attribute create, do exactly what we did before, call it myvar, and leave it as a point, and let's give it some arbitrary value, doesn't matter what it is. Now I'm going to make this a detail attribute, which means there's only one attribute for the entire network. We can see that here if we go to the detail level. There we have myvar 1, 2, 3, 4. So let's now use an attribute promote SOP. An attribute promote SOP is a method to copy attributes between different levels. So what I'm going to do is take this attribute, which is a detail attribute, and it's myvar, and I'm going to make it into a point attribute. Now the promotion method here is very important when you're changing the type of attributes from attributes which have many values across a piece of geometry, for example a point attribute, and changing them into something which has fewer values across geometry. In this case, because we're changing in the other direction, this is really not very relevant. I'm going to change it to first match. And let's have a look and see what that's done. Well, it's taken our attribute here off the detail level, and that's because we've got delete original selected. If we have a look at our point level, we now have an attribute called myvar with the value. What about doing that in the opposite direction? So let's create a point attribute, and let's give it a random value. And now let's promote our point attribute to a detail attribute. And now this promotion method is very important because we've got several values being collapsed into a single value. We need to know how to combine them, and Houdini allows you to find the maximum, minimum, the average, sum, and so on of the values at point level as you raise them up to detail level. So here let's, for example, find the sum. And now if we have a look at the detail level, we find that the sum of all of those earlier values is 40.88. That's not a particularly useful example. Let's have a more useful example. I'm going to use a measure SOP. And a measure SOP creates an attribute based on the measurement of aspects of your primitive. So in this case I'm going to get the area of each of our polygons, and I'm going to put it into an attribute called area, which we should be able to see if we look at the primitive level, and there we have it, area. Now it might be quite useful to know the total surface area of our entire object. Well, that's easy to do with attribute promote. If I lay down an attribute promote SOP, I then take the primitive attribute that we've just created, area, and I make it into a detail attribute, and we take the sum. And now if we look here at the detail level, we can see that the total surface area of our sphere is 20.61. Let's look at transferring attributes between different bits of geometry. I've gone back to our standard point level attribute. Let's assume that we've got another sphere and that we want to move this attribute which we've got on the points of this sphere to this other sphere. Well, we can do that using an attribute copy SOP, which has two inputs. We can middle click to see what they're for. This is the geometry to copy the attribute to, so that's this sphere here, and this one is the geometry to copy the attributes from. Now we need to tell it which attribute to copy, so in this case we're going to copy an other attribute, and we type in myvar. And what we should find is that this sphere, which is now the geometry that's going to come out of this node, has a point attribute called myvar. Now notice that because I have made this a primitive sphere, it's only got one point, 0, but myvar has still been created and it's been given a value, and that value has come from the 0 of our original sphere. So this attribute copy is not doing anything very complicated. It's just taking the point number of the geometry coming in and getting the attribute for the equivalent point number on this geometry. Now to make it work well, you need to ensure that your two bits of geometry have exactly the same number of points. And now we should find that we have myvar properly created on all of our points. Well, finally, let's look at how to transfer attributes between bits of geometry that have different numbers of points or primitives. And we can do that using an attribute transfer node. And I need to set up some geometry to transfer attributes from, so I'm going to use an add SOP. An add SOP just is a way of creating a single point. So that we can see it, get rid of the origin. And we can see there we've got a single point. And I'm going to give it an attribute. And I'm going to call it myvar again. And I'm going to give it an arbitrary value. And this time I'm going to give it a default. So the attribute transfer takes two inputs, one of which is the geometry which has the attribute, and the other one is the geometry we want to transfer the attribute to. And if we have a look at the details view, we find that our sphere now has myvar set for each of the points. There are some controls here which allow you to set a distance threshold. Because what's happening here is our point at the origin, let's just template that, our point at the origin is transferring its attributes to all of these points on the sphere. And we can set this distance threshold so that points which are too far away don't get the attribute. Let's take this right down and then see what our details view produces. Well, the attribute is still being created, but it's being given a different value. It's being given the default value we set up here rather than the value we set here. Note that the attribute transfer SOP does not decay a value as it gets further away. This is an absolute cutoff. So, for example, here we have a value of 1223. What we can't do using attribute transfer is give points further away a proportion of this value and points very close the full value. You either get this value or this value. Well, I hope that's been a useful introduction to using attributes and expressions in Houdini.